Welcome to my channel Kuda Edutainment TV, where we focus on educational content. So in this series I'm doing computer science IGCSE syllabus. That's what I'm doing. So I also do computer science AS up to A level and other subjects like ICT, computer applications technology, computer studies, computer literacy, as well as mathematics grade 8 and 9. So please share my video, comment, like and subscribe. Please subscribe to my channel. I want to reach 1000 subscribers by end of September. This is the goal that I have set, so please help me achieve that goal by sharing, subscribing to my video. Alright, so today we want to look at logical shift. So logical shift, it is a way of multiplying and dividing unsigned binary numbers. So there are two ways we can do logical shift. We can do logical shift left and we can also do logical shift right. So by logical shift left, we are creating empty spaces to the right, and by logical shift right, we are creating empty spaces to the left. So when you create these empty spaces, you populate these empty spaces with zeros so that we maintain the number of bits our register or binary number has. So this is what you're going to be dealing with today. So our question says, perform a logical left shift of 1 on the register 00101101. So what you simply do, we draw this register. So it's an 8-bit register. So 1, 2, 3, 4, 5, 6, 7, and 8, and then we populate. Then we need to draw another table like this one, right, which will have the new register after we have performed the logical shift. So this would be our new register after the shift. 3, 4, 5, 6, 7, and 8. Now our register 00101101, right? So remember, we said logical shift left, we are creating empty spaces to the right, empty spaces to the right. So what you're simply doing, we are throwing away, because this is our left side, this is our right side, so we are throwing away this bit, right? We are throwing away this bit, meaning to say this bit will now occupy the first position. It will now occupy the first position in the new register, which is 0, and this bit will now occupy the second position, this one, third position, fourth position, fifth position, sixth position, and seventh position. And remember, we said we are creating empty spaces to the right, and what we do, we populate empty spaces with a 0, right? So let us write these registers: 1 0 1 1 0 1, like this. So we have performed a logical left shift of 1 on this register. So let us see the effect that it has. Let us see the effect that it has. So by doing that, we simply have to convert this first binary number into its denary form, and then we convert this into its denary form. Then we compare the two, the change that will have happened. So on this one, this is an 8-bit, so we have 128, 64, 32, 16, 8, 4, 2, and 1. And the binary units that are switched on here, we've got 32. 32 plus 8 is 40. 40 plus 4 is 44. And then here we have 45. So here we have got 45, that's the value. And then on the new register, what's the value that we have now? We have got 64, 16, right, 8. So 64 plus 16, it gives us what? 80, plus 8 is 88, and then plus 2, 90, right? 90. So if you compare these two dinar numbers, 45 and 90, what has happened is that logical left shift of 1 has multiplied, right? It has multiplied our first binary number by 2 for us to get the second binary value, right? So this is how we do it. We simply convert this number into binary, this binary number into dinar number. We also convert the result into dinar number. So on this one is 32 plus 8, it's 40 plus 4, 44 plus 1, 45. And then on the result, we have got 64. 64 plus 16, it's 80. 80 plus 8 is 88. 88 plus 2, we get 90. So that's the effect that it has, the logical left shift. So we want to perform logical right shift on the same register, right? We want to do logical right shift and see. Now we want to perform logical shift, right? Logical right shift. Logical right shift. So by logical right shift, we are simply creating an empty space to the left. So meaning to say, we are throwing away the rightmost bit. We are throwing away the rightmost bit. We are throwing this away. So we want to create an empty space to the left. So what happens is this one will take the last position, the second last position, third last position, right? Fourth last position, fifth last position, sixth last, seventh last position. Then the empty space that we've created here to the left, we simply populate with a 0, right? So we write these bits: 0 here, 1 here, 1 here, 0 here, 1, 0, and 0. So this is the new binary number that we now have after performing right shift of 1 on this binary number. So now let us see the effect that this shift has on the binary number. Remember, we converted this to 45, so we want to convert this to find the corresponding dinar value. So we now have the units that are switched on now. We have 16, we have 16, we have 4, we have 2. So 16 plus 4 is 20, 20 plus 2 is 22, right? So this is, right, maybe let me write 128, 64, 32, 16, 8, 4, 2, and 1. So 16 plus 4 is 20, plus 2, 22. So this one gives us 22. So the effect that the right shift has, right, on this binary number is that it has divided this number by 2. Of course, we couldn't get 22.5, but if our original binary number that we have shifted, if it was adding up to an even number, then we were going to get, let's say if this was 44, we were going to get, maybe, let's say if it was 48, right, we were going to get 24. Here, we couldn't get 22.5 because we don't have commas in binary numbers. That's why we got 22 here. So this is how logical shift works. So that was the video. It was all about demonstrating how to perform logical shift or to the right or to the left, or only using one place. So in the next video, I'm going to demonstrate how to perform logical shift of 2 places to both left and right, and then we'll conclude as to what type of effect does it have. So on this one, logical left shift is multiplying the number by 2, and then logical shift right is dividing the number by 2. So please subscribe to my channel, share the video, and contact me on WhatsApp on the numbers appearing on the screen, and also follow me on my social media platforms using the description in the links in the description below. Thank you very much. See you in the next video.